As the economy grows, the logistics industry plays a vital role in supporting trade, distribution, and supply chain efficiency. In that context, I would like to introduce VIETLOGISTICS, a company established in 2015. Since its founding, VIETLOGISTICS has built a warehouse network across southern Vietnam with facilities in Bình Dương, Ho Chi Minh City, Đồng Nai, and Long An. With a total capacity of about 50,000 to 70,000 square meters, the company provides both ambient storage areas and limited temperature control areas. These warehouses are suitable for FMCG products, food, beverage, personal care, and household goods, as well as manufactured items like electronic components, furniture, and home appliances. Besides warehousing, VIETLOGISTICS operates a diverse trucking fleet supported by GPS tracking, helping ensure safer and more reliable deliveries. With strong warehousing and transport capability, the company is a trusted logistics partner in southern Vietnam. As the CEO of VIETLOGISTICS, I'm really proud of everything that our company has achieved. Our growth, strong operation, and trusted service has made VIETLOGISTICS become a reliable partner in southern Vietnam. And in the future, we aim to expand globally. Behind business growth, there is an environmental cost that cannot be ignored. Warehousing and logistics contribute significantly to pollution, waste, energy consumption, and CO2 emission. In the next part, we will analyze this issue and explore possible solutions. Let me start with a typical delivery process. In a normal logistic flow, goods move from a distribution center to a regional warehouse, then to city warehouse, and finally to the final consumer. Although this looks like a simple delivery chain, each step creates environmental impact. The first is fuel consumption, which mainly comes from transportation, since trucks use fuel whenever goods move on the road. The second is energy consumption, which is mainly concentrated in warehouses where electricity is needed for lighting, storage system, handling equipment, and all the operations. So when we combine these two aspects, you can see that logistics make a significant contribution to greenhouse gas emission. So as shown on the slide, logistics account for 11% of global emissions, including 8% from transportation and 3% from warehouses and ports. Around 2.8 billion tons of global greenhouse gas emission come from the logistics and transport sector. In terms of energy use, warehouses consume about 2.1 million tons of oil equivalent compared to 5 million tons for light goods vehicles and 7.7 million tons for heavy goods vehicles. So thus, we can see that warehousing is not only a storage point in the logistic chain, but also a source of energy consumption and emissions. Inside the warehouse, energy is used for several activities such as heating and cooling the building, ventilation, lighting, IT system, and transport equipment. Among these, the largest part of warehouse energy consumption comes from building heating and cooling, which take about 65 to 75%. After that, transport equipment accounts for around 8 to 15%, and lighting contributes around 7 to 10%. So even small equipment like forklifts can consume a lot of energy and negatively impact the environment if we don't know how to use them properly. So now, let's deep down on specifically material handling system, especially its forklifts. As shown in this chart, the environmental impact of forklift operation mainly comes from fuel use and exhaust emissions. The key point is that exhaust emissions are much higher than fuel consumption itself, especially when the forklift operates with load. But even when driving without load, forklifts still consume energy and generate emissions. At this point, maintenance becomes very important. Studies show that poor maintenance can reduce both performance and safety, while also increasing energy-related impacts. For electric forklifts, battery condition is critical because aging lithium-ion batteries may generate more heat and create safety risks if not properly monitored. In addition, worn tires can reduce efficiency, increase repair costs, and even lead to accidents. So more generally, regular services is essential for maintaining safety, efficiency, and cost control. If maintenance is neglected, it can lead to more breakdowns, unplanned downtime, higher repair costs, and shorter equipment lifespan. So our company, VIETLOGISTICS, at the present is using an electric counterbalance forklift with a 2.5 capacity and an 80-volt lithium-ion battery. And our company is specific. Our forklift is facing two main problems. The first is poor routing optimization. Forklift may travel unnecessary long distances, take insufficient routes, and make empty trip, which increases energy consumption and reduces efficiency. The second is the lack of forklift health monitoring. Since there is limited visibility into the current condition of each forklift, maintenance may be delayed and equipment may not be used in the most effective way. So these two core issues lead to one core problem: the lack of visibility and intelligent fleet management. Because the company cannot clearly monitor each forklift current health score, it becomes difficult to optimize routes and assign tasks efficiently. So the real issue is not only about the forklift itself, but also how to manage the forklift fleet in a smarter and more integrated way. In order to address the core problem, I suggest a solution called AI-based forklift management system. The main idea of this solution is to connect warehouse order information, forklift health condition, and the route optimization into one integrated system. Instead of assigning forklift manually or only based on availability, the system uses AI to determine which forklift is the most suitable for each task and the route is the most efficiently. Now, let me briefly explain how the overall workflow operates. First, the warehouse management system sends task information such as pickup point, drop-off points, priority, and due time to the forklift management system. Then, the system calculates the best route for the task while also check the health score of available forklifts. Based on both the route and the forklift condition, the system selects the most suitable forklift and sends the task information to the driver device. While the driver is performing the task, the system collects operational data, including travel time, battery usage, delay, and task status. These data are then analyzed by AI to evaluate efficiency and predict maintenance needs. So the operating method is not just about assigning forklift, it is a continuous cycle of task allocation, execution, monitoring, analysis, and predict maintenance. So one of the most important part of our solution, that is the forklift health score. So that is really the core idea of the whole system, because it helps to solve the main problem we identified before. We do not just need route optimization, we also need to know which forklift is actually the right condition to perform the task. So the forklift health score can be understood as a combined indicator showing how suitable a forklift is for operation at a specific time. It reflects the forklift mechanical condition, maintenance status, operational stability, and risk of breakdown. Based on the score, we can classify forklift into 4 levels. If the score is around 80 to 100, the forklift is healthy and can be assigned normally, including medium or high priority tasks. If the score is 60 to 79, it is the running range. The forklift is still useful, but some of the components are degrading, so it should mainly be assigned to lighter tasks. If the score is 40 to 59, it is at risk. In this case, the forklift should be inspected or maintained soon, and its task assignment should be limited. And if the score is 0 to 39, it is critical. That means there is a high risk of failure and unsafe operation, so the forklift should be removed from normal use and prioritized for maintenance. So overall, the forklift health score is evaluated based on 4 main factors: operational performance, technical condition, safety-related behavior, and maintenance history. Based on these evaluation factors, the forklift health score can be applied in 2 main ways. The first application is AI-based predictive maintenance. Using the health score and operational data, the system can predict the likely failure type, such as battery, hydraulic, or motor issue, recommended the maintenance priority, and suggest a system maintenance window. This helps reduce unexpected breakdowns, downtime, and maintenance costs. The second application is intelligent assignment. Here, AI combines the forklift health score with other operational factors such as route efficiency, battery level, current availability, task priority, and predictive maintenance risk. Based on that, the system can track whether a forklift is truly fit and reliable for a specific task. So coming to our web interface, I would like to introduce our first page, which shows the main dashboard of the forklift management system, or FMS. Its purpose is to manage a real-time overview of fleet operation, task execution, and maintaining status in one place. The real-time task map shows the warehouse layout and the current position of the forklift. The fleet status overview summarizes how many forklifts are available, busy, charging, or under maintenance. The performance overview displays key indicators such as on-time completion, idle time, and battery usage. The AI task dispatch queue show pending tasks and recommend the most suitable forklift based on priority, destination, SLA risk, and forklift condition. Finally, the predictive maintenance alert highlights forklifts that may need attention before a serious breakdown occurs. So coming to the next page, the order information is first sent from the warehouse management system to the forklift management system. This includes the pickup point, the drop-off points, and the side forklift for the task. Based on the information, the system generates the optimized route inside the warehouse. In the route parameter sections, the system can define the routing priorities such as the shortage time, minimum distance, avoiding congestion, and lowest battery consumption. This allows the route to be adjusted depending on operational need. In the route performance comparison section, the system compares the AI-generated route with a manual or conventional route. It shows key indicators such as estimated travel time, estimated battery consumption, contraction avoidance rates, and on-time task prediction. This helps managers see why the recommended route is more efficient and reliable. Coming to the next section, this shows the AI assignment recommendation. Based on the task requirements, the system ranks the available forklift and recommends the most suitable one. The recommendation is not based on availability. Instead, AI considers several factors such as forklift health score, expected completion time, battery condition, and operational risk. As shown here, each forklift is evaluated and compared, and the system explains the reason behind the recommendation. This helps managers choose not just an available forklift, but the one that is most efficient, reliable, and fit for the task. So coming to the final page of our web, that is AI predictive maintenance and health score. Its purpose is to monitor forklift condition in real time, predict potential failures, and support maintenance planning more proactively. First, the fleet health overview shows the health score of each forklift. It provides a quick view of overall condition, including aspects such as battery health, mechanical health, high hydraulic pressure, and safety stress. This helps managers identify which forklifts are still healthy and which ones need attention. Second, the real-time failure prediction section highlights possible faults before they actually happen. For example, the system can detect hydraulic pressure spikes or abnormal vibration and estimate the risk and timing of failure. This allows prevention action instead of waiting for breakdown. Finally, the maintenance work order management section helps organize maintenance activities. It shows active work orders, technician assignment, repair status, and scheduled downtime, so maintenance can be planned with minimal disruptions to operation. So coming to our final section, about the cost planning, the budget is divided into three parts: one-time build cost, monthly operation cost, and a reserve fund, where the total budget is $35,200. So I plan to implement this solution within 2 years, 2026 and 2027, including four main parts: planning design, core development, AI development, integration and pilots testing, risk management. I focus on three main potential risks: operation risk related to task assignment errors, forklift breakdown, or root issues that may disrupt warehouse activities; technical risk involve integration problems, unstable real-time data, or inaccurate AI output. People-related risks come from user resistance or difficulty adopting the new system. So to manage these risks, the solution includes pilot testing, phase implementation, manual override, fallback procedures, regular validation, and user training. I focus on, and this is our reference. Thank you for paying attention, and hope that you will have a nice day.